Hello students, as in the today's lecture we're gonna do very important topic, very important concept, the three important type from the chapter, as I divided this three type as type number 4, type number 5 and type number 6. I hope you all understood the type number 1, 2 and 3. In type number 1, 2 and 3 also we had divided like that. Type number 1A, type number 1B, type number 2A, type number 2B, type number 3 and type number 3B. So here it is the type number 4, 5 and 6. These three types are very important type, very important concept from the chapter. Okay, so now we'll see how to remember this type. As type number 4 is what? Integral 1 upon a plus b sin x. That means the given integral question, it will be in the form of 1 upon a plus b sin x. What is a and b? It is the number. There will be a number. We can say the coefficient. A and b will be replaced by the number. Remember this, a and b in type number 4, 5 and 6, it will be replaced by the number. Okay, and the format is fixed. In the numerator it should contain only 1. So can you see type number 4, type number 5, type number 6, in the numerator it is 1 only. So it is fixed that when it is 1 and here it is a plus b sin x, if this is the format, perfect format, then only we can apply the type number 4. If suppose here it is something different, in place of 1, suppose there it is sin, cos, we cannot apply the format. The given integral question, it should be in this form only, integral 1 upon a plus b sin x. For example, a and b will be replaced by some other number. Suppose a is replaced by 2 and b is replaced by 3, so 1 upon 2 plus 3 sin x, we can apply this format where a and b is the number. Okay, or else sometime the sign will be replaced by cos x. Sometime sin and x cos x will be together. Sometime the format will be like this, 1 upon a plus b sin plus c cos x. So whatever the format, but for all the four format, the step, the method, the concept remain same. Just remember the type number 4 as in the numerator there will be 1 and in the denominator you will have sometime sin x or sometime cos x or sometime both sin and cos together. So just simply remember the type number 4 as sin x and cos x. Okay. Now we'll see type number 5. Type number 5 is what? Your sine, can you see your sine cos is replaced by what? Sin 2x and cos 2x. Rest it is same. So you can remember the type number 5 as in the numerator you will have 1 and in the denominator you will have sine 2x, sometime you will have cos 2x, sometime you will get both sine 2x and cos 2x together. So in simple language, type number 4 you can remember as sin x cos x. Type number 5 you can remember as sin 2x cos 2x. And type number 6 you can remember as, remember this type as, here it is sin x, here it is sin 2x and here it is sin square x. Here it is cos x, here it is cos 2x and here it is cos square x. So here in the numerator it will be 1 and in the denominator it will contain sin square, cos square or sometime both together. Okay, I hope you all understood how to remember this type. So this is the format of the question. These are the format of the question. So in simple language, I will say remember the type number 4 as sin x cos x, type number 5 as sin 2x cos 2x, and type number 6 as sin square x and cos square x. So let's begin with the type number 4 first. Okay, so let's see the format, let's see the methods, steps, what all things we have to do and how to find the answer for the particular integral question. Okay, so here we have some steps also which we have to follow. As type number 4, as I told that the given question it will be in this form. Sometime the given question will be in this form, 1 upon a plus b sin x. A and b will be replaced by the number. Sometime the given question it will be in this form also, 1 upon a plus b cos x, or else it will be in the form of 1 upon a sin x plus b cos x, or sometime it will be in the form of 1 upon a plus b sin x plus c cos x. Okay, so whether it is in this form or in this form or in this two form, for all the four form you have the fixed step. So these are the fixed step which you have to follow whenever a given integral is in this form, whether the question is replaced by sin x or it is replaced by cos x, or sin x and cos x are together. These are the fixed step which you have to follow. Okay, so what is the step that we'll see first? Okay, so whenever the question for the type number 4, numerator should contain 1, that is the first thing. A and b will be replaced by the number, that is the second thing. And in the denominator it should contain only sin x or cos x. Okay, sin x and cos x, only sin x and cos x. So this is the format only for the sin x and cos x, remember this. Okay, now so here the first step is what? You will start with let, you will take tan x by 2 equals to t. Remember this is the fixed format which you have to remember. You can remember like this: sin cos, sin cos, sin cos, sin upon cos, it will be tan. Sin upon cos is what? Sin upon cos is what? Tan. So in it is just to understand. Okay, it's not fixed that because here sin and cos is there, so we have to take let. Just it is in a tricky way. Just remember this format as the question it is in the form of sin cos. So sin upon cos is what? Tan. So here we took let tan x by 2 equals to t. Okay, and why x by 2? As there are two, can you see this two formula? As there are two formula, this two formula actually it is a trigonometric formula. I hope you all might be knowing this sin x and cos x formula, which is known as half of the angle also. So here sin x is what? 2 tan x by 2 upon 1 plus tan x by tan square x by 2, and cos x it was 1 minus tan square x by 2 and 1 upon tan square x by 2, 1 plus tan square x by 2. I hope you all might be knowing this. Actually this is not integration formula, it is a trigonometric formula which is known as half of the angle. So whenever it is sin x and cos x, so here clearly we can see that here we have x by 2. X by 2 means half of the angle, so that's why I took here tan x by 2. Understood? And we know that sin and cos is what? Tan. So sin cos is tan. As here this trigonometric formula it is in the form of half of the angle, so that's why I took here half of the angle, that is x by 2. So here for this sum, whenever you come across sin x and cos x and numerator contain 1, so you will always start with let x by 2 equal to t. Okay, then after that what you will do? After that, first step it will be tan x by 2 equals to t. Always you will start with let. And as I told in the previous video also, whenever you take let in integration, whether it is first exercise, second exercise, third exercise, in integration let means what? We have to find the derivative of that particular term. Okay, so now first we'll do the little adjustment, and then after that we'll find the derivative. And of course the derivative we have to find with respect to x only. So first we'll shift this tan to that side, so tan will go that side, so this will be tan inverse, yes or no? After this we'll shift this 2 to the right hand side. Now adjustment over, so now we'll find the derivative with respect to x. So derivative of x is what? 1. 2 is constant, will keep as it is. Derivative of tan inverse t, I hope you all might be knowing derivative of tan inverse of x is what? Derivative of tan inverse x is what? 1 upon 1 plus x square, yes or no? So here it is t, so this will be 1 upon 1 plus t square, but here x is replaced by t, so we'll apply the chain rule. So derivative of t will be what? dt by dx, yes or no? because here for this part we are finding derivative with respect to x, we are not finding derivative with respect to t. Yes or no? So tan inverse is what? 1 upon 1 plus, as we know that tan inverse of x is 1 upon 1 plus x square. So here x is replaced by 2t, so this will be 1 upon 1 plus t square. But here we are finding derivative with respect to t, so derivative of t will be what? dt by dx. I hope this all basic things of derivative you might be knowing. Okay, so after this what exactly we'll do? After this we'll bring this dx to the left hand side. This part will be 2 upon 1 plus t square into dt. So here we got dx equals to 2 upon 1 plus t square into dt. That means in simple language, whatever the integral we will have, the question we will have, this each and everything it will get convert into t, alphabet t. Each and everything it will get convert into alphabet t. Even the dx will get convert into dt. So here we got dx is actually equals to 2 upon 1 plus t square into dt. So whenever in integration, whether it is first second exercise, whenever we take let to a particular thing, okay, as for the particular thing here we took t, so that whole question, the whole part, it will get converted into t itself. Okay, so now I hope you all understood till here. Now as we know that the format of the question is what? Either the question will contain sin x, or it will contain cos x, or it will contain sin and cos both. So we have to replace the sin x also, na? As here dx we got, dx answer it is in t. Now we have to find the answer of sin and cos also in terms of t. To find the answer of sin and cos in terms of t, here we have two formula of half of the angle. So sin x is equals to what? 2 tan x by 2 upon 1 plus tan square x by 2. We know that tan x by 2, here we took what? Tan x by 2, here we took what? T. So in place of tan x by 2 I replace that tan x by 2 by t. 1 plus tan square x by 2, so this will be what? T square. Because tan x by 2 is t, so here we have tan square, so we'll write t square. I hope you all understood this part also, because here as I told, the whole format it will get converted into t. So even the dx will get converted into t part, even the sin x part also it will get converted into t. So this is the format in which method or format we can say, in which we have to convert the sin x also in terms of t. Cos x is what? 1 minus tan square x by 2 upon 1 plus tan square x by 2. Yes or no? So we know that tan x by 2 is t, so here we have tan square, so we'll write t square. Tan square x by 2, tan x by 2 is t, square is there, so we'll write t square. So here we converted sin and cos also in terms of t. Got the point? And this two formula, actually it is not an integration formula, it is a trigonometric formula which is known as half of the angle. I hope you all might be knowing what is half of the angle. Okay, so that was the step number 1 which you have to apply whether the given question that is in this form contain only sin x, contain only cos x, contain both sin and cos. Okay, the format step number 1 will be fixed for all the 4 question. Okay, whether it contains sin and cos together, the step number 1 will be fixed. Okay, so now what is the step number 2? Step number 2, here I clearly mentioned that replace sin x, cos x and dx into t. As in the step number 2, you will replace sin x, cos x and dx in the given integration question with t. So given integral will convert into what? It will get convert into 1 upon quadratic, and we know that 1 upon quadratic actually it is known as what? Type number 1a for us. Yes or no? As I told, to remember each and every sum, not exercise wise, remember each and every sum as a type wise, so it will be helpful for us to solve the sums. Okay, I feel keeping the sum in type wise, it will be better than the exercise wise. Okay, so now for each and every format of the question, each and every sum, it will get converted into what? It will get converted into type number 1a. So in the first lecture, when we were dealing with the type number 1a, that time only I had told that type number 1a will play an important role in the integration chapter. So can you see, type number 1a is very very important, because type number 1a, it was there in type number 1b, and here also it is playing an important role. And I hope you all might be knowing what is 1 upon quadratic. And when it is 1 upon quadratic, we know that how to solve. First you have to make the coefficient of x square 1, the symbol should be positive, apply the third term, yes or no, adding, subtracting, and then after that, the given format, it will get converted into either in the form of integration 1 upon x square plus a square, or it will get converted into 1 upon x square minus a square, or it will get converted into 1 upon a square minus x square. And this also I had explained, whenever the symbol of x square term is negative, always and always you have to apply the third formula. And whenever in the question itself only it says that the symbol of x square is positive, so you have to apply the first and second formula. Only third formula you have to apply whenever the symbol of x square is negative. So let's take one example based on the type number 4, so then you will understand how to apply the step, how to apply the format, and how to find the answer easily. Okay, so let's begin with the first example. Here we have integral 1 upon 3 plus 2 sin x. As clearly we can see that this look like this format, whether it is sine, cos, sin x, cos x, the method will be fixed. The simply, in place of sine, sometime it will be cos, and sometimes sine and cos will be together, but the format remains same. So here also first step will be what? We'll start with writing let tan x by 2 equals to t. After that we'll shift, just now only I had explained this part, this section, how to solve. Okay, so tan will go that side, so this will be tan inverse t. After this we have to shift this 2 to the right hand side. Okay, now we'll find the derivative with respect to t. So your derivative of x will be 1, 2 is constant, will keep as it is. Derivative of tan inverse t will be 1 upon 1 plus t square, but we are finding derivative with respect to x, so t will be what? Dt by dx. After this we'll shift this dx to the right hand side, left hand side, sorry, 1 plus t square into dt. So here we got the answer for dx, yes or no? Now as we know that the formula for sin x is what? Half of the angle formula, tan x, 2 tan x by 2 upon 1 plus tan square x by 2. So therefore we'll replace this tan x by 2 by t, so this will be 2t upon 1 plus t square. So here we got the answer of sin x also in terms of t. And we know that cos x is what? 1 minus tan square x by 2 upon 1 plus tan square x by 2. So we'll replace tan x by 2 by t, so this will be 1 minus t square, and this will be 1 plus t square. I hope you all understood till here. So this is the step number 1. Okay, so now we'll see what exactly we have to do in the step number 2. We'll replace sine, cos and dx by t, and the given integral, it will get converted into what? 1 upon quadratic. So now we'll see how it will get converted into 1 upon quadratic. So here as we have I equals to integral 1 upon 3 plus 2 will replace this sin x by what? 2t upon 1 plus t square, yes or no? And dx by what? dx by what? 2 upon 1 plus t square into dt. So here I had clearly mentioned that you have to replace sine, cos and even dx also in terms of t. So here we have the value of dx. So dx is what? 2 upon 1 plus t square into dt, that I had wrote here. And sin x also, it is in terms of t, so sin x is what? 2t upon 1 plus t square. Perfect. Any doubt till here? Okay, after this I equals to 1 upon 3 plus, so this will be 2 to the 4t upon 1 plus t square into 2 upon 1 plus t square into dt. Next basic adjustment you have to do here. We'll shift here, nothing is there, so we'll write 1, cross it, so you will get what? 3 plus 3t square plus 1 4t side is 4t upon 1 plus t square. Just a basic algebraical cross multiplication, yes or no? Understood? After this, okay, we'll reciprocal this part. So here you will get 1 plus t square upon, okay, so here can I say that it look like a proper quadratic equation? So first we'll write t part, then t square part, then we'll write 4t and then we'll write 3. We had converted in the form of ax square plus bx plus c. Understood? Then into 2 upon 1 plus t square into dt. As clearly we can see that here multiplication is there and this section is common, so we can cancel it. So I equals to, so here we left with 2 upon 3 t square plus 4t plus 3 into dt. I hope you all understood till here. Okay. As per the rule, we know that we required 1 upon quadratic equation. As the given part, it should get converted into 1 upon quadratic, yes or no? So in the numerator, we required only 1. As the format also, it says that in the numerator, it should be 1 only, yes or no? 1, 1, 1, 1. So to make this part as 1, so we'll bring this 2, as 2 is a number, it is a constant, so we can bring that 2 easily outside the integration and we can write as 1 upon 3t square plus 4t plus 3 into dt, yes or no? As now we had converted the given integral in this form, after replacing the value of sine cos dx into t, it is get converted into what? 1 upon quadratic. And we know that what is 1 upon quadratic? It is a type number 1a, and we all know that. I hope you all might be knowing how to solve the type number 1a. Okay, so now here clearly we can see that it is a quadratic, but here the coefficient of square part is not 1, so we'll make this part as 1. So we'll bring this 3 outside the integral, so this will be what? T square plus 4 by 3t plus 1, bracket open with this 3, so you will get 3t square, 3 will get cancelled, you will get 4t, and 3 1 z is 3. I hope you all understood this step also, how to make the coefficient of x square 1. Got the point? Here I made the coefficient of x square as 1 and symbol should be what? Positive. Already the symbol is positive. Okay, so after this we'll apply the third term. For third term, half into coefficient of x here, but we are dealing with t, yes or no? So coefficient of t is what? 4 by 3 the whole square. So 2 ones are 2 twos are, so here we got 2 upon 3. So 2 square is 4 and 3 square is 9. So after this what we will do, we'll write 2 by 3 1 upon t square plus 4 upon 3t plus 4 upon 9. Add that. I hope you all might be knowing the rules. We have to add that number to alphabet and subtract that number to number, yes or no? Okay, so after this 2 by 3. Okay, so just check first and last part. So this will be t plus 2 by 3 the whole square, as this part is look like what? A square plus 2ab plus b square, we can write as a plus b the whole square. Just solve this part in the rough work and check, you will get this answer. So clearly we can see that this part look like a square plus 2ab plus b square, so we can write as t plus 2 upon 3 the whole square. Further cross it and see 9 minus 4, so this will be 5 upon 9. So I equals to 2 upon 3 integral 1 upon t plus 2 by 3 the whole square. We'll convert this part also in whole square. So 5 it is, we can write as root 5, and 9 we can write as 3 the whole square, as we know that root 5 is the irrational number, we cannot find the square root of 5, so we have to write as root 5 only, yes or no? I hope you all might be knowing how to solve type number 1a. Okay, so now done with this, just simply we have to guess the format. It look like what? So this is the x part and this is the number, and here we have plus, so here we have plus, first part is x, second part is number. So actually this format, it is in the form of integral 1 upon x square plus a square, yes or no? So it is in the form of 1 upon 1 upon tan inverse x upon a plus c. So we'll integrate with respect to t now. So the answer will be what? 1 upon a. So what is a over there? It is root 5 upon 3, root 5 upon 3 into tan inverse x upon a. What is x over there? It is t plus 2 by 3 upon a is root 5 upon 3 plus c. Okay, so we had removed the integral, so that's why I wrote here plus. After this, a basic adjustment will do. 2 upon 3, this part we can write as 3 upon root 5 into tan inverse, just cross it, so this will be 3t upon 2 upon 3 upon root 5 upon 3 plus c. Here 3 will get cancelled as multiplication is there, so this we can write as 2 upon root 5 tan inverse, this 3 will also get cancelled, so here we let fit 3t plus 2 upon root 5 plus c. And the last step will be what? Resubstitute the value of t. So what was the t we took? T, it was tan x by 2. So we'll replace the t by tan x by 2 plus 2 upon root 5 plus c is the final answer which we got for this sum. I hope you all understood the method, the format, the type, how to remember the type. It is very simple. Just now only I had explained type number 4. In short, you can remember type number 4 as 1 upon sin x cos x. Sometime the given question, it will be in the form of sin x. Sometimes the given equation, it will be in the form of cos x, or sometimes sin and cos, it will be together. And what is a and b? A and b is the number, constant, coefficient. So here a and b will be replaced by the number only, okay? And the numerator, it always should contain 1. In place of 1, if there it is sine, cos, tan, we cannot apply this. method. Okay, remember this. So I'd explain the method also. Whether the format is sin x, cos x, or sin and x come together, still you have to apply the same method, same format. Step number 1 and step number 2 will be same. And in the for all the format, all the cases, whether it is sin cos or sin cos together, each and every sum it will get converted into in this form, 1 upon quadratic. And what is 1 upon quadratic? I hope you all might be knowing. It is your exercise number 3.2, I guess, or else you can remember this type as type number 1a. So here each and every sum, whether the format is sine cos, whether the format is sine cos, sin x and cos x, in step number 2 what you will see that each and every sum it will get converted into type number 1a, and we know that how to solve the type number 1a. Here we took one example in front of you. Step number 1. Step number 2, we have to replace sine cos and even dx also in terms of t, and when you will see, it will get converted into 1 upon quadratic form. And after that, I hope you all might be knowing the rule. What is the rule? The coefficient of x square should be 1 and the symbol should be positive. Apply the third term, basic adjustment, apply the suitable formula, and we know that when to apply the third formula, whenever the symbol of x square is negative, we have to stick with the third formula. Then the basic, after that, don't forget to resubstitute the value of t. After resubstituted, then if you feel, you can solve the basic step, like here we did cross multiply cancellation. After that you can stop your answer. I hope you all understood the type number 4. We'll take one more example based on this.